Right, welcome back, Year 5. Here we are with electricity, and today we are looking at conductors. Okay, and there's three conductors of electricity. They'll allow electrons to move through them easily. Copper wire, there's a paperclip, and there's actually a graphite pencil. I bet you didn't know that. Graphite in pencils is a type of mineral that lets electricity move through it. And you've got insulators. Here they come. Okay, and there's some insulators too, some glass, some wood, and here of course we've got some rubber, which of course goes over the wire, so the electricity doesn't come over the wire, out of the wire and get us. Okay, so you've got some insulators there, and these insulators don't let electricity travel through them. That's why we call them insulators. And there it is, guys, in black and red. Conductors allow electricity, electrons to flow through freely, and insulators do not allow electricity, electrons to flow through freely. And if you haven't written that down, you probably should write that down because that's very important. Okay, and there's our copper wire, which is just the best conductor you can have. That's why we use copper wire and electric wires, because that just transmits the electrons all around our house and our various places that we live. And down the bottom of the screen is wood, of course, which is an insulator. It just does not move electricity at all. It will not conduct electricity at all. Thank you. And that's why if someone's been electrocuted, you separate them with a big block of wood. You don't grab onto them because you'll become electrocuted as well. You just give them a sensible whack with a piece of wood. Okay. Okay, team, here's a standard circuit. I'm sure you recall that this here is a bulb. I'm sure you remember this is a battery. And I'm sure you remember this part is just a wire. Well, let's see what happens if we put inside this gap here, because right now, of course, the bulb's not lit because there's a big hole, isn't there? Okay, there's a big hole just here. All right. What happens if we put in the copper wire? Can you tell me what's going to happen? What happens if we actually connect the copper wire properly to fill up the gap? And let me fix up this bulb here. That looks terrible. All right, that's better. It's fixed up now. What happens when we put the copper wire in? Well, tell me. Yes, because the copper wire is a conductor. Because the copper wire is a conductor, the electrons will now be able to flow around through the conductor, through the light bulb, turn on the light bulb, of course, and back to the positive end of the battery, and the light bulb will go on. However, what will happen if we try to join? We'll fill the hole with wood in our circuit. So there's the hole in the circuit, and we put some wood in the hole, okay, the broken bit of the circuit, and let's see what happens now. What do you think's going to happen? You tell me. Okay, what would happen is, of course, the electrons would try to go around, off they go, and they would go clonk. They would stop. They are not getting through the wood. Wood will not conduct electricity. Wood is, in fact, an insulator. It means it doesn't conduct electricity. Let's just briefly look at all of the insulators and all of the conductors. Okay, guys, here's your basic conductors. You've got your copper wire, you've got your paper clip, just any sort of metal. You've got your graphite, which is a bit of a type of metal in the pencil. You've got these gold coins, another metal, because, metal is a big conductor. And you've got water. Guys, really important to remember. Metal and water always conduct electricity. Let's have a look at some of the insulators. Okay, you've got glass, doesn't connect electricity. Sorry, said that silly. Glass doesn't conduct electricity. You've got wood, does not conduct electricity. You've got... Okay, they're your basics, but for those of you who are really smart and want to know something interesting, if electricity is strong enough, it will actually get through anything, even if something's an insulator. For example, a bolt of lightning, if it hits a tree, it's going to take that tree apart. So basically, we can say, guys, insulators generally don't conduct electricity unless it's very, very strong. And conductors, well, they always conduct electricity. Okay, guys, thank you very much. Any questions?